Let us continue our discussion with the colligative properties and its advanced level problems. We must realize that advanced level problems does not necessarily mean that they are tough. It may be the case that they are designed in such a way so that it appears to be tough. Let us see this problem. The question is relative decrease in vapor pressure, which of course is a colligative property, so relative decrease in vapor pressure of an aqueous NaCl is 0.167. So this value is already given. Number of moles of sodium chloride present in 180 gram of water is, out of these options, which one? So we have to find out the number of moles of aqueous NaCl present. So obviously it's an aqueous solution. So if it is aqueous solution, definitely the solvent is water. So solvent is water. Now the point is, what is the formula? The formula of relative lowering of vapor pressure is equal to how much? I into X B, that is the mole fraction of solute. We must realize that what is RLVP? It is nothing but P0 minus P divided by P0. I hope all of us can remember that. So RLVP is given 0.167. So let us put, so I'm just rewriting this one once again. RLVP is equal to I into, now XP, mole fraction. Mole fraction means it is NB, number of moles of B, divided by Na plus NB. Let me clarify. This NB stands for number of moles of solute, and Na is the number of moles of solvent, which is water in this case. So let us rewrite. So it should be NB divided by Na plus NB. Now let us figure out. RLVP is already given in the question, which is 0.167. So I am writing that 0.167 I, Van 't Hoff factor. So NaCl is obviously an electrolyte, strong electrolyte. So it will be dissociated to Na plus Cl minus. So initially there was one particle, now it is 1 plus 1, 2. So I value should be 2 by 1, which is 2. I hope it is clear. Now here it is 2. Now NB, number of moles of solute. Check the question. We have to calculate that, the number of moles of solute. So NB will be as it is, Na, number of moles of solvent. Now in the question it is given 180 gram of water. So number of moles of solvent means it is the given mass by molar mass. Molar mass of water is 18 plus NB. So from here we should be able to solve the value of NB is how much. You calculate. After calculation we are getting the value of NB is equal to 1. So as per the given options, I think option B is the correct one, 1 mole. The next problem is also quite similar to the previous problem that we have faced. Here the question is relative decrease in vapor pressure, which is same as the relative lowering of vapor pressure, is 0.4 for a solution containing 1 mole of NaCl in 3 mole of water. So relative lowering of vapor pressure is taking place. 1 mole of sodium chloride is taken in 3 mole of water. So here the question is the NaCl percentage. So 4 options are given. Let us find out. It is NaCl solution. NaCl solution. So obviously if the solution is NaCl, that means solute will be sodium chloride and solvent will be water. So if the non-volatile solute is mixed in water, the relative lowering of vapor pressure will take place. So RLVP, which is P0 minus P divided by P0, is equal to I into XP. We know that. Now, how to proceed? Question is the percentage of NaCl. That means how much NaCl is taken in, say, 100 gram of water. So to find it out, let us find out the value of this I. Means I will decide whether the dissociation has taken place, and if the dissociation has taken place, then how much dissociation has taken place. Because from the value of I, we can find out whether it is association or dissociation. Obviously NaCl, there will be a dissociation. How much the dissociation is. From there we can find it out. Now, let us find out. Here, RLVP, if I rewrite, is equal to I into NB divided by Na plus NB. RLVP value is 0.4 is equal to I into NB value, this one. We all know that, just I am rewriting. So here you see the I, we have to, obviously for NaCl we can directly write down the I, but let us find out the value of I using the other values. That means it will be 0.4 I into the number of moles of solute, which is 1 mole of NaCl, by 1 plus 3. Remember, 3 mole of water, 1 mole of NaCl. So we are getting 0.4 is equal to I by 4 actually, because it is 1 by 4. So I value should be 0.4 into 4, which is 1.6. Interestingly, if we need to find out that how much dissociation has taken place, that is alpha, for that we are carrying out a very simple calculation. Suppose NaCl is Na plus and Cl minus. Although it should have been 100% dissociated, but since in this question the percentage is asked, so suppose 1 mole of NaCl was giving rise to 0 and 0. Now if it is 1 minus alpha and it is alpha and alpha, in that case what will happen? The value of I should be, the total mole after dissociation should be 1 minus alpha plus alpha plus alpha. So it will cancel out, so it should be 1 plus alpha. So the value of I should be, as we know, number of moles after dissociation, that is 1 plus alpha divided by 1, which is ultimately 1 plus alpha. So in this case, we are assuming that formula, that I is equal to 1 plus alpha. Now, I is equal to 1 plus alpha is equal to 1.6, because I value we have already calculated. So the value of alpha should be 1.6 minus 1, which is 0.6. As we know, we always calculate that in percentage. So it is 60% dissociation because it is 0.6. So as per the given question, you can see the option A is the correct one. Our third problem today is also related to the relative lowering of vapor pressure only. Here, the question is the vapor pressure of carbon tetrachloride at 25 degrees Celsius is 143 mm mercury pressure. 0.5 gram of a non-volatile solute whose molar mass is given 65 gram per mole is dissolved in 100 ml of CCl4. Density of CCl4 is given here 1.5 gram per milliliter. Then vapor pressure of the solution is how much? 4 options are given. Now let us figure it out first. So the formula of relative lowering of vapor pressure, as we all know, is P0 minus P divided by P0 is equal to xp. Here it is non-volatile solute which is dissolved. Nothing is mentioned. So we can think that the value of I is equal to 1, that we can think of. Let us see here what are the values which is already given. P0, it is the vapor pressure of CCl4 which is given, of course. P0 is 143 millimeter mercury pressure. P, we have to find out the vapor pressure of the solution after adding the non-volatile solute. xp, on this side, it is xp means here we are talking about mole fraction of solute. Let us see. So as per our previous concept, we know that suppose xp we are writing, we know it is nb divided by na plus nb, and since nb is far greater, I'm rewriting, and since na is far greater than nb, so we should be able to write na plus nb is almost equal to na. That the assumption we already calculate. So xp we can write as nb divided by na. Better I should write equal to sign here. So we are using that one here itself. So let us rewrite. It is P0 minus P divided by P0 is equal to nb divided by na. So that we have to calculate. On the other side, let us find out nb. It is the number of moles of solute. How much is given in the question? It is 0.5 gram non-volatile solute. The molar mass is 65. So straight away let us calculate the value of nb, which is nothing but given mass 0.5 divided by molar mass. Calculate this. If you calculate, you will get 0.00769. I had calculated already. Na, here how much CCl is dissolved? 100 ml of CCl4. So volume directly cannot be calculated. So we need to calculate how in 100 ml how much CCl4, how much mass of CCl4 is actually there. So for that its density is also given. So we can use this formula. Density is equal to mass by volume. So mass should be equal to density into volume. Density is given. Density as per the question, it is 1.583 gram. 538 gram into volume, which is given as 100 ml. So if we calculate, we are getting 153.8. That is the mass. And if we want to calculate the molar mass, which is Nb, which is 153.8 divided by the molar mass of CCl4. Now we need to calculate the molar mass of CCl4. I am calculating here only. CCl4 means it is 12 plus 4 into 35.5. Calculate this. We should be getting 154. So here it is 153.8 divided by 154, almost equal to 1. So on one side we are getting the value of Nb which is, it should be Na actually. Sorry, it should be Na because it is solvent, which is CCl4. Na should be this much, and Nb, as we have mentioned, we had already calculated, which is 0.00769. I repeat, it is Na which we are calculating because carbon tetrachloride is the solvent here. So it is almost 1. Now in the original formula, P0 minus P divided by P0 is equal to Nb by Na. P0 is how much? P0 is 143 minus P divided by 143 is equal to Nb, means it is 0.00769 divided by 1. So from here we are going to calculate the value of P. You calculate the value of P here, you will be getting around 141.9 millimeter mercury pressure. That will be the answer. You do calculate this much carefully. It's very easy though. Calculate the value of P. You will be getting 141.9, which is given in the first option. So this one is correct.